Hey everyone, thank you so much for joining us. Welcome to another live stream of on.NET Live. So this is where we have tons of our folks from the community and across the .NET ecosystem come in and talk about some of the really cool and interesting projects that they're working on. Now, this is pretty much like an offshoot of our regular on.NET show that we have on Channel 9. So if you haven't seen it before, I definitely recommend you go ahead and check it out. You can head over to channel9.msdn.com and you could see the past recordings of some of these sessions. And you could also see some of our pre-records where we talk about tons of other products and services. Now, in today, we have Nick who's going to come on. And I'm a big fan. I'm really excited. Nick has been in the .NET ecosystem for a very, very long time. He's created tons of interesting projects and tools. So I'm really interested to talk to him today and kind of figure out what's he working on today and talk a little bit about diagnostics with Serilog. So, hey, Nick, how are you doing today?
Hey, Cecil, I'm good, yeah. Really nice to be on the show. Seeing a few people popping up in the stream there. It's kind of
yeah. I think folks are really excited to see you in here and chatting with you as well. Why don't you really quickly introduce yourself and tell folks a little bit about like who you are and what do you do today?
So, yeah, I started working in .NET way back around about probably almost in 2000 when it first appeared on the scene, just in dribs and drabs. But I think probably the first open source work that I did that people have come across would have been AutoFac, and I worked on that on the side as a consultant way back, working on enterprise apps. It's probably the most well-known bit of work I've done. But that after that, I joined the .NET team at Microsoft. I was working on the MEF library, which was very much related in back in the .NET 4 timeframe, and a lot of other BCL related things then. But I'm not actually at Microsoft anymore. That was long enough ago that people remember kind of like Windows 8.1, or Windows 8, Windows 8.1, those kinds of crazy bits of tech. That was my time. And since I've been working on Serilog, which is another pretty popular bit of code in .NET, still keeping involved in the .NET world and digging deeper into diagnostics in a company I founded to build a log server product called Seek, which is my day-to-day at the moment.
Nice. And we definitely want to talk about Seek, and I want to talk about like some of those really cool things that you're doing in terms of like diagnostics in the .NET space. But I also kind of want to acknowledge some of those previous projects that you used to work on. Like I remember when I actually first started using dependency injection, many years ago, my first job as a .NET developer, like AutoFac was the thing that I used many years ago. I've used it like in almost every other project since then, up until the point that .NET had its own dependency injection framework in there. But AutoFac was like my default. It had all the extensions I needed. It had the performance I needed. And it was just such a flexible and great tool to use. So personally, I want to start off with saying thank you, because you were able to influence a lot of my projects that I've worked on over the years. And even with Serilog now, you're still doing that, and I'm sure tons of other folks in the chat think the same thing as well.
Yeah, that's been awesome. And I mean, I remember way back when. I mean, I was there when you were working on those projects. I remember you popping up back in those days. I think that's the most exciting thing about open source, when you run into people working in completely unrelated areas sometimes, but little bits of code that you've worked on are getting used there. I think that was one of the most exciting things about AutoFac that got me maybe a bit addicted to the whole world of open source, because meeting somebody at a conference who's kind of using software that you worked on day to day, who can often tell you a bit about it or a bit about it that you possibly wouldn't even really realize yourself, it's a really interesting experience. It's kind of like we all become this collective mind that that improves and works on these projects. So once they're released out into the world and everybody starts to push them different directions and see what works and what doesn't, open source is like a really interesting kind of amplification of people's ideas. So I've become, I guess, I don't work on AutoFac anymore, so I probably should say that anyone working on it, anybody using it today is probably benefiting from most of the work that the current maintainers have put in over the last several years.
Right.
But even from when that code was released, it stopped being something that was my creation and started to become a really big organic kind of community creation. And I think it's a much better piece of software for that. A lot of my early ideas kind of got shelved or pushed out over time by better ideas. I definitely became an expert in that little domain, but it was not so much just my own expertise that let that happen as, running into people like you who are using it in different ways and finding ways to improve it back then. Open source is a really interesting addition to working on software in enterprises for pay, because the dynamic's just completely different.
Right.
You're kind of always providing the solution when you're working in paid software consulting or development, but in open source you kind of provide the initial push, and the solution sort of seems to eventually come to you.
Right. I was really curious to find out, what was the thing that got you to get involved in open source community? Like when you started to create your projects, AutoFac and others, was it just automatic that you were like, oh, okay, I'm just going to make this thing and I'm going to make it free and open source? Or was there something else?
It was probably recklessness in a way. I was working as a contractor at that time, or I was initially, and in my downtime between contracts, sometimes I would work on a little bit of code, learn something new, maybe scratch an itch. And I remember I just finished a contract at the point that I really started working on AutoFac in earnest, and I wasn't working with anybody else day to day. At that point, I just was working, from my house. And so the only way to really get any kind of feedback on that, and IOC was, pretty far out territory back then. It's not like it is today. In 2007, when I really worked on AutoFac in earnest, you could go to a meetup in a major city that would be packed with .NET developers, and you would be really hard pressed to find anyone who had any idea what IOC was about. So once I started to become really interested in the problems that it poses, like the classic problem that got me hooked into AutoFac was, if you have this container that's creating all of these components and they need to be cleaned up at some point, well, the container needs to clean them up. And, you'd be familiar today, I guess, with creating scopes for dependency injection where components that have been created during, say, a web request all get disposed at the end. Pre-AutoFac, those ideas in IOC I felt were quite ad hoc. And AutoFac was an attempt to really kind of formalize a lot of ideas around that to make managing resources in complex apps a lot easier. But of course, even my colleagues who I spent a lot of time working with, in related bits of code, work-wise, weren't really interested in this sort of far out area of research. So putting AutoFac out on the net was a bit of a punt, and the turning point, I think, was when people actually started to pop up who were thinking about the same problems too, and who were really interested in that, right, in that little area at the time. And it really, even just meeting one person online who's working on the same kind of weird esoteric niche that you are, it's a real motivator. And I think the first at least year of AutoFac in open source was really just driven by that. We were just working on something fun.
Right. And it's interesting too, because kind of like what you mentioned before, a few years ago, like that pattern of building software, of using, DI containers and IOC and those types of things wasn't like a commonplace pattern for a lot of .NET developers. And, something must have happened, within that period of time where everyone's like, I really care about modularity. I really care about testing my applications. I really care about the ability to program against interfaces and swap things out in a very non-invasive way. And all of a sudden, I felt like now there's a rush, right? Like now, DI in every app that's built is almost like the default, Yeah.
I think we have to thank the alt.NET movement back then for that kind of set of, IOC is just one tool, as you said, in that set of related practices, with where you've got unit testing and you've got kind of separation of interfaces from, their implementations. I think a lot of those ideas, they were not themselves, I guess, new ideas, but under that banner of alt.NET that I think we worked on at the time, that whole sort of set of practices got mushed together into something that eventually became coherent. And when we were working on it in 2007, 8, there was still a lot to kind of figure out, like application to application, if you wanted to apply practices like unit testing. I think that the turning point must have been once we'd all in the alternative kind of arena threshed out all those, I guess, found all of those rough edges and figured out the problems. Then that set of practices became really cohesive, and we have a lot of tools and techniques now that just fit together naturally. And so that I guess makes it a lot easier for people who are just starting new apps to jump straight in and set unit testing up and set IOC up and get those kinds of benefits without having to invest a whole lot of sort of research time into figuring out how to make that work.
Right, that's true. I'm not a fan of like following the crowd, right, and doing the popular thing sometimes, but what you do get from that is the fact that there's now a lot more folks to be able to ask questions, right? And a lot more people that are creating content and blog posts and videos and those types of things. So the level of resources are different. And so, I'm sure a lot of folks have opinions of how should I use DI, right? And the right and wrong places and anti-patterns and all these types of things. But again, I think what's important now is that we do have really good guidance. We have a lot of research and a lot of battle-tested applications that could prove the point, right? And so, I think
we have the validation.
Sure.
I shipped this.
Right, exactly. I think that's a great thing that we're able to do now and leverage. And I'm really interested to see what's going to be the next thing that we see in terms of software architecture, not just in terms of like containers and those types of things, but from a code perspective, like what are some of the next patterns that we're going to see emerge, coming forward in the next 4 or 5 years that it's going to really affect how we write code.
Yeah, I've been looking for that too for a long time, because that's where a lot of the appeal of exploring things like dependency injection originally came from for me. I have a feeling it's probably mostly moving up the stack. Like we've seen a lot of change in how we deploy apps, Kubernetes and Docker, those kinds of, or the cloud. I don't really feel like when I write C# today, I'm writing code in a fundamentally different way to what I would have been 10 years ago now. It's definitely become much improved, but I do see that push towards, like, once everything's running in the cloud and all usage is kind of metered, then like the actual cost of running code itself is becoming a core driver. And so I think a lot more efficiency is still yet to be squeezed out. I see there's work going on in .NET around ahead of time compilation, those kinds of things.
Right.
There might be a couple of phases to that, in that initially, we add ahead of time compilation, and then we find that there's a whole lot of patterns that don't fit anymore. One thing I'm really excited about is I see in C# 9, I think the upcoming version, there's talk of source generators where at compile time, libraries can get involved in kind of looking over the abstract syntax tree or concrete syntax tree in C# land and emit code that becomes part of the build. And so then tools like IOC containers, say, that do a lot of, at the moment, dynamic runtime instantiation of stuff with reflection, or using really complex IL emit type methods. A lot of that work can move to build time. So instead of registering all of your components kind of on the fly when your ASP.NET Core app starts up, I'd expect within a few years there'll be a pre-compilation, or there'll be a pre-compilation code gen step that's happening in the background to wire up a lot of those instantiation kind of things. I think that's only really just the tip of the iceberg for what we could do with those kinds of features. I've been working a little bit in Rust as well recently, and it's got a really strong kind of compile time macro evaluation story, and a lot of the things that we use reflection for in .NET are being done at build time with like code gen type macros in Rust.
Right.
And I think that's going to I don't think that we'll see the same thing exactly materialize in C#, but as we're trying to make things start up faster and, especially because they're metered, I think we're going to see the shape of libraries and things start to change a lot in .NET to start to try and bring that work forwards to build time that we're doing at runtime now.
Yeah. I think there's going to be definitely post .NET 5 wave that's coming. There's going to be a lot of different patterns and habits for folks that are building libraries and consuming those libraries as well. I can also see people becoming a lot more conscious about things like the jitter, becoming more conscious about things like performance and the testability and reflection, like you said, and the performance of those things as well. But because I definitely want to keep talking to you about this stuff, because I know we could talk about this forever, but I want to make sure we have enough time to dive really deep into like the Serilog and the analytics stuff. And I'm looking in the chat, and some folks are still joining us from like all over the world. I see there's some folks here from Costa Rica. We have some folks from Brazil. So hello to everyone. Thank you all so much for joining us.
It seems sorry.
No, I'm sorry. Go ahead. Yeah,
I see a couple of mentions of Serilog in there too. We probably are jumping around.
Yeah, folks, they definitely want to hear about it. So why don't we start off with this? Because I'm curious about how you went from working on AutoFact to now, for me anyway, being the person that really brought structured logging to .NET. And maybe I don't want to disrespect anyone if someone else has done it before. I apologize. But for me, until I saw Serilog, like that was my first foray into that and thinking about logging.
Yeah. So logging itself has been around obviously since probably the 50s, whenever we started rubbing two bits together to, like logging where you print lines of kind of output as your application runs to tell the story of what's going on internally in that application. Structured logging is probably almost as old as that, but it's not ever been truly very popular. I was first introduced to it when I was working on a nasty legacy system in a complex organization, and I think at that point we had somebody collecting log files for us from the production server, and I think that they must have done it via RDP, which we weren't really allowed to do. And sending those back for analysis, and we get these piles of text logs and work through trying to figure out what was really going on in our app. And sometime around about then, the Patterns and Practices group at Microsoft, Grigori Melnik, I think, was primarily driving the project, released a thing called the Semantic Logging Application Block.
Right.
Yeah, and it was kind of like a .NET API to this structured logging implementation that's been in Windows ever since, I think, NT, or way back, somewhere around there. It was my first kind of exposure to the idea that events, instead of just being text, could actually be fully structured JSON, potentially objects that then I could use tools to filter and analyze without having to go and write regex.
Right.
The data that we were getting from in our text logs back then as well, you could see that it was really interesting data. We could have found all sorts of info about trends and how people were using the product. But just because it was so laborious to get that info out, we could really only hope to get to, I know why it's crashing. And structured logging was interesting because it kind of made the suggestion that we could get up to like, how's it being used, or just trivially answer those kinds of questions that we had about the code. And the data was there, but it was just too expensive really to pull it out. So Slab, the Patterns and Practices tool, introduced me to that idea. But Slab had a different interface to what we used for logging in .NET then. So Log4Net and every other logging framework back into the beginning of time has an interface where you really are just treating it like a console. You say log.info, write, print, something like that.
Something like that.
Yeah, and Slab, as interesting as it was, required that you created a class to represent a log source, and you had to create a method for every log event that you were going to emit. So the idea was awesome, but for me, switching over from where I'm writing code and I just want to quickly drop a log event in, to have to go and sort of tab over to another file or create another class, add a method, figure out what its parameters were, and then go back to where I was working and call it, was just too much friction for me to actually want to make the switch to structured logging. And I figured that was probably the case for everybody else.
Yeah.
So Serilog was just one of those random thoughts at the moment. Like, what if we tried to mush these things together again and have an interface that looks very much like Log4net, but that can still preserve the structure of the data that's getting logged through it. So for people who are not really familiar with Serilog, Serilog is a library that you can sort of print log events to, but when you pass parameters into your kind of print, your format string, instead of those parameters getting formatted into the text, we actually keep the format string and then we serialize the parameters so that later on, if you want to turn it into text and read it like a text log, you can. But behind that log event, even though you can see it as text, we've captured those parameters. Like you might be checking out a transaction, and the transaction ID is going to be in the message somewhere, like checked out transaction 5. Behind the scenes, where you pass that 5 through, we keep that so that later on you can filter transaction ID equals 5 and find those events without having to go and try and differentiate that 5 from every other 5 in a gigabyte text file. Yeah, so from that little thing, obviously very much the same process as AutoFact. That became an open source project, and then a lot of people jumped in and said, "Hey, wouldn't it be cool if we did this?" And and so from that it grew into something that was it was mature and I guess influential enough by the time that .NET Core was first being conceived, that there was like an affordance made in the .NET Core logging implementation. I think Lou Desjardins spent his time on that back then. And so even though today we sort of have that capability everywhere, like nlog, Microsoft extensions, logging, and Serilog are the most well-known ones. The ideas have kind of been, I guess, developed through that long history of trying to apply Serilog in all different kinds of places. I should explain the name too, I guess, because there's often a bit of confusion. It is a pretty odd name for a logging framework.
I was going to ask you that. I was going to ask you to tell us where the name came from.
Yeah, when you it's probably got more than a few. It's probably got more than a few too many coinages in there. But when you capture a log event and you record the kind of template string, the format string, and the parameters, you serialize those parameters. And so it's a serializing logger. And it helps if you think of it that way, because a lot of the time things that are reasonable to pass to a traditional logger, like here's this EF entity I just pulled from the database, they're not. If you switch on kind of the structure capturing of Serilog, which you need to opt into with a little @ sign before the name of that parameter, but if you switch that on, you serialize those parameters. And so this is the kind of thing that we had to spend a few years working out the rough edges in, because serializing an entity framework entity that's connected via lazy loading to every other entity that's in your database can become rapidly like a gigabyte of JSON stashed away. So Serilog, as it grew over time, we had to work really hard to try to make it as robust and reliable as any other logging framework. But yeah, it's a serializing logger, and so that's where the name originated.
Right. So I kind of wanted to share a little bit of a story about how I thought about logs as I kind of went through my career. Because I think it might be helpful, particularly if we have any folks in here that are new to programming or new in the early stage in their career. It might be helpful to kind of get some insight. And when I first started developing software, like young .NET person, I was working on these very small applications. I wrote a lot of small applications, and for us, diagnostics wasn't a thing. Like diagnostics was, we're hosting things in Windows, and I would just go and look at the Windows event log for crashes, right? But even though we see the crashes, I wouldn't know the path, right? Like I wouldn't know what happened before or after. It was a little tedious to get that type of information. So then we started to do file logging, right? And kind of like what you said, like file logging was just, hey, exception, throw this exception and then log a file to the file system, right? And so then at some point you'd go into your web server, because again, we were just on a single web server. This wasn't like a cloud situation. We go into the web server and now there'd be, file txt with like a date, right? And there'll be like dozens and dozens and dozens of these. And then we have to go in and clean them out and, rotating file logs and all these types of things you had to deal with and manage. And then at some point we moved forward and I was like, maybe we should store these things in a database, right? So what does it look like to store your logs in a database? Because now like I want to search them, right? And I want to search by particular properties and keywords. And I think at that point I was like, oh, maybe something like Serilog makes a lot of sense now. Now I get it, right? Like, and I think for me, like I had to do it to get it. You know what I mean? If you're just like, hey, just use this thing and it's cool. But then now I had the problem, and so I completely understand the use case. Yeah,
with a database, I guess you can think of Serilog as being like a way to capture the columns. You've got a log table, it's got a timestamp and it's got a message. But if you really want to effectively use that data, you need to populate some other columns with some kind of info you can filter on. And I guess that's where the role of Serilog starts to become clearer. I tried all sorts of crazy ways to record structured logs. Back when Serilog was new, we had document databases of all kinds and SQL Server. There's a humongous set of different syncs for Serilog out there now too, which probably is much or more of the project than the core is. Like the core is only a few thousand lines of code in the end, but I think actually finding ways to store logs that preserve the structure and make it nice and easy to search was half of the challenge of the project. Right.
And you're right. Like I remember when I go into NuGet.org and I search for Serilog
it's like reams of paper,
right? And I know there's some that the Serilog team, you and your colleagues support and create. And I know there's tons of other third-party ones for different databases, different targets.
And even
Insights and Splunk and all kinds of things.
Even strange things like Kafka and like Azure Event Hubs and send logs anywhere. Now, I think Serilog's particularly strong in that set of syncs because when you're just recording text logs, there aren't really a lot of useful places that you can store them. Ultimately, if you're going to search them, you're either going to search for them in a file or you're going to use a log server of some sort that's specialized for dealing with that sort of text data. But once your logs are these kind of events that have got a message and then a whole bunch of kind of properties, just about anything that accepts JSON or can deal with JSON becomes an interesting target to send logs to. I don't think that we really do enough of that kind of like event-oriented analysis of logs still. Like I imagined in the beginning of Serilog that there'd be a lot more use for kind of pattern detection and anomaly detection because you're really just dealing with events and logs are really unscientific, but events have had all sorts of energy and effort put into them over the years, and so I think there's a lot still to really do to start. Like we can search logs easier now because of Serilog and Microsoft Extensions logging and those things, but we're really only just starting to scratch the surface of what's possible once we start treating them as kind of like real-time event streams from apps.
Right. So we've spoken a lot about Serilog and events and things like that. Would it be possible if you show us really quickly like what does it look like to just create like a simple Serilog thing? I want to create like a simple log in Serilog. Like what would that look like?
All right. Yeah. I think I can probably. I just realized there's probably one package missing. You've got my screen, haven't you?
Yeah. I got your screen. Yeah. Could you make the font size just a little bit bigger?
I didn't think of that, did I? I wonder if I can Control+.
You might be able to, maybe.
No.
No?
Okay. Sorry about the text size. We might just be stuck with it for the time being, unless we're going to see me fiddling around with settings. Okay. So I just need to add one more package.
Okay, so you're Serilog formatting.compact. Okay.
Yes, because I think so. What we'll have a look at first is so this is Serilog's kind of classic console application setup, right? So we can configure Serilog. We're going to write to the console. It's in a try finally block because a lot of Serilog syncs will send those events to different destinations asynchronously. And when your app exits for whatever reason, you really want those flushed. We could have also just taken the return value of this and put it in a using block, but having the global log.logger initialized is pretty handy for different reasons. Okay. So this is Serilog. Okay, and that's pretty familiar kind of a log statement. If I run that, I actually have to hit F5 instead of 5. We'll see that pop
pretty
up.
Straightforward, right? Like you have a static log type, right? And I could just say log dot information,
yeah,
log dot whatever,
log dot warning, dot error. Yep. So that's really the kind of logging that we would once have done. If say the name of the person that we're greeting, or the entity in this case, is stored in a variable, then you might think that this is the kind of case where you might do string interpolation in .NET perhaps and say hello name,
right.
And that will give you very similar looking output. But I think understanding the difference in this point is kind of where the aha moment is for why Serilog is different. So if we format that data now into name, we end up with just a string logged and there's no special data attached to it.
Right.
We can actually see that by saying we can change the output now to just show the properties of that log event. And we'll have to, okay, I'll leave it temporarily like that. You can see there are no properties attached to that event.
Right.
So if we want to use Serilog effectively, what we need to do is preserve that data. So we don't use interpolation, which came to C# a little bit later than Serilog did. We give the property a first class name, and that's what's going to be attached to the event that we generate. And then we pass that name through. And that's exactly the same as if we were to write a format string in .NET. In fact, we could write it as a format string, and the code would still produce the output we're expecting. But in Serilog, that placeholder there is the property name, and this thing that we're creating is what we call a message template. And I'll leave the properties token as our output. Actually, sorry, no, I won't. I'll do it another way, because properties doesn't actually show properties that are already in the message. It's just a little. I'll write a JSON version.
A little bit of extra.
It's a little bit of a usability enhancement because you end up with a lot of junk in there if you've already got the properties embedded into the messages that way. So we'll show it as JSON instead. And now you see we're actually writing to the console twice. Hey, if you've used logging frameworks if you've used other logging frameworks in .NET, you might be surprised that we're not writing XML or something like that right now to configure these things. Serilog's very code first. Though you can use XML. It's a little bit of a second class citizen. But now we've got some more interesting output. In this example now we've got hello.net, and you see that .NET is in a kind of a blue color, and that indicates that the property is actually being captured behind the scenes. And if you look at the JSON representation of that event, we have hello name as the template that we're recording, and name has been serialized as .NET. We can add more properties to, let's say hour. And we'll say,
and you could do a daytime and pull that out, I guess.
Yeah, and you can see what time of the day that I've gotten up to talk to you all. So hello.net at 7, and you see that in the JSON representation, we didn't just capture 7 as a 2-string representation there as well. It really has been serialized as the number 7. Right. And that's interesting because we can then filter on those logs if we want to record them somewhere that's aware of JSON to find all of the events where hour is between 5 and 8, for example. Right. So we're not dealing with text at all anymore. This is really the definition of an object and a template, and the rendering that you see at the console here is really just one possible way of showing how that data is displaying that data.
Got it. And so we do have some questions We have a lot of questions actually that are popping up now. I want to make sure that we get to some of these. So we have a question here. This one is coming from YouTube, and Lior is asking, nlog has the ability to write log file with the process name in it, but I didn't find that option in Serilog. Does it exist? So can we write?
Sure. Yeah, that's a good question. Yeah, nlog does. Serilog does have a facility to do that. It's called serilog.syncs.map, and I'm not as familiar with nlog as I probably should be, but in Serilog's world, that map sync can create file names out of any property that's attached to a log event. I don't know if you can still see my screen. Is that possible there?
Yeah, we're still looking at your screen.
Okay, so we can say in Serilog, events are usually enriched with additional properties. So we'll add here process ID. Yeah, we use this. I don't think that's the way that .NET would format it. And we'll just, actually, it's going to be process ID. Let's say process ID 1, doesn't matter. Now, there are packages to do this, obviously, automatically from the actual process ID in the Serilog world. I don't have them installed right now.
Right.
And when we run that, you see that even though that event now has, it's the same event at the console, but you see the hour is there and process ID is attached. So the map sync is a way of taking any property that's attached to a Serilog event and including it in things like file paths, connection strings, database names, or those kinds of things. So I think that's a good illustration of where Serilog's kind of view of events as being structured data really changes the way that it's designed. There's not sort of like a lot of special casing around things like processes and threads and stuff like that. These things are all just properties that events are enriched with, and so then the kind of sync ecosystem has ways of manipulating and working with those properties. So mapping events to different files based on the process ID or changing the file name to include it is just one sort of special case. You could equally well create files by thread ID or even by customer name if you have that data attached to your log events.
Right.
And of course, there's a lot
of these properties. Like these properties are, and I don't want to downplay it, but these properties are key value pairs. It's like a dictionary, right? Like
that's all it
name
is.
and a value.
Yep. Yeah. I'd love to field the question about thread safety, but I don't know if. I'm not sure if anybody had asked it, so I think we can dodge that one.
Sure, but no. Well, we have tons of other questions that we could talk about. So thank you, Lior, for that question. I'm going to look down and let's look at some of these other comments that are coming in. Lior also made a comment. Real time is very important. I use gRPC extension in my log viewer to stream logs in real time during debugging from many processes to a single viewer. So that's pretty interesting. So that's
cool. Yeah.
We have another one. We have a lot of questions from YouTube. So this person is asking, what about mocking in unit tests? Are there any best practices for such a case? So I'm guessing you're talking about mocking the logger, I'm guessing?
I would guess so. And maybe this is where it's interesting to chat. Basically, opinions differ on this point, and it's probably a bit contentious. You see that I do use this static log.logger type, and when I write events, they are using this kind of static approach where we're not injecting the logger in here. If I pull that out into a method, for example, it can be a static method. I don't need to accept. It might be called say hello. I don't need to accept the logger through. The .NET. Some of the popular .NET frameworks, perhaps ASP.NET Core principally among them, do use dependency injection to accept iLogger into constructors. And that, I think, is the approach you would use if you wanted to make your logs kind of mockable for testing. But see, I've kind of ended up leaning the other way, where I feel like logging is such an ever-present concern that it's really just noise in constructors. And if you've worked on a large MVC app, for example, you'd have seen controllers that have constructors with 20 parameters. Having iLogger passed into the constructor of every controller for me detracts from me being able to see that constructor and understand how that controller fits into the rest of the system. Like the fact that a controller can log is not interesting to me. Like every controller should log. And given that logging as well is usually something that we kind of want to do in a cross-cutting way, there's not often a lot of cases where I want to have completely different logging pipelines attached to different controllers, for example. Like you could do that if you wanted to, and that would be a valid way to approach it. But to me, most of the apps that I've worked on that are real world generally have one logger running somewhere kind of right back from the very beginning of the project or beginning of the app's execution.
Right.
And all of those events are going to the same place at runtime. So I don't use dependency injection with loggers, and I don't mock loggers in testing. I don't test log events through unit tests. I test log events by debugging the app during development with my logs. So while I'm doing kind of feature development, every time I hit F5, I'm watching those logs, and when something goes wrong, the first question I usually ask myself is, if this went wrong in production, are these logs that I'm looking at right now sufficient for me to try and understand what happened then?
Right.
So I think testing logs is not so much a matter of testing that they're emitted, but it's testing subjectively as a human that they're actually going to carry the right information for you to get out of a tight spot. Because, I mean, testing that a class emits a log event when something happens is one thing, but if your site's down and that log event is the key to figuring out how to get it back up again, then the actual data in that log event and how it relates to the rest of the system is the important thing. Like you don't really want to have an extra 1,000 unit tests running in your test suite that just ensure that useless log events have been created. Like it's better to, for me, remove all of the friction around adding logging and focus on them as more of a user interface kind of a concern. And that I find is good for me as well, because I don't feel any guilt about adding a log event and not adding a test to ensure that it was raised. Like I add log events, I don't like them, they're too noisy, I remove them again. I don't go and update tests anywhere, but all the time, whenever I'm looking at code, I'm trying to improve the logging so that it's more, diagnosable once I'm actually relying on those events. I think if you had infinite time, you might test log events. I just don't feel like I do.
Sure. I think another thing, like we could look at it from another approach as well. I think because Serilog is so customizable, one of the things that I've done in past applications is when I'm running my quote unquote production app, I have it read a certain set of configuration, because you can configure Serilog in your app.settings file, or, it can be in code, but it doesn't all have to be in code. Right. And so now when I'm running my unit tests, and I do Serilog read from configuration, I would probably pull out a different set of configuration. So now it has a different target, right? So maybe in production, I log to some data store, or I log to Seek or something like that. But then in production, in unit testing, maybe I just log to the console, or maybe I only log to, maybe I have like a dev tests, instance that I could target my stuff to.
Yeah, sometimes in testing and most of the time I don't log at all. I mean the logger is unconfigured, and that's okay, because those methods like log information and log error, they won't throw when there's no logger configured.
Right.
They they'll just sit there quietly and do nothing, which is what I think that they should most of the time be doing.
Right. So now we also have some questions coming in from Twitch. I want to make sure I get to some of these as well. We have someone called Small Fluffy Rodent. Really interesting name.
Hi.
And hi, Small Fluffy Rodent. And their question is, I've never used Serilog, so this might be a silly question, but what happens if the logger crashes? In brackets, he has throws an exception.
Oh yeah. Okay. Now that is also really interesting. So Serilog originally was modeled very heavily on .NET. On Log4net. Definitely modeled on .NET as well. No, Serilog was modeled very heavily on Log4net, and I tried as much as possible to take lessons learned from Log4net and apply them Serilog. I think one of the guarantees that Log4net makes is that logging should never throw, and setting up logger configuration, for instance, might throw depending on how it's done. But calling log.information should be something that I can do without. It's again about the friction of being able to add log events. I don't want log.information to be another potential failure point in my program. And so Serilog by default will suppress all exceptions that come back through the logging pipeline that way. So I call log.information. I wanted it to go to a database. The database is not available. My program will just go on, without missing a beat. And I mean, logging is not something that should bring your production app down. Or if you're in the process of unwinding because an exception's been thrown, you shouldn't throw a new exception when you're logging that exception, for example, and mask what was originally failing. So not having log statements fail is a pretty important feature, I think, of Serilog, but it doesn't mean that you can't view that information. So internally, Serilog has a feature called self-log, which you can turn on with something like self-log enable, and that gives you an actual text message, console.writeLine m, which we would probably call as just a delegate there. And so when that happens, an event like an exception that's raised within the Serilog pipeline will end up at the console. You can send that to other places, but it will still not cause your program to fail. If on the other hand, you do want logging statements to fail your application, which people in some situations do want. For example, if I'm about to charge, say, a credit card, and I absolutely must log that fact before I go out and try and make the charge, which is the sort of auditing scenario that you hear about in some kind of applications. Serilog has a system called Audit2, and Audit2 gives you some other options. They're very much, if we were going to install, say, the file sync, let's switch over to here and we can add the file sync. You'll see that we get write to file sync, and if write to file fails, we won't see any kind of exception raised, but we can add audit to and configure a log file there. Oops. We can configure a log file there, and then when we make this log statement, when we raise this log event here, any of the write to syncs, if they fail, the exception won't propagate. If we can't write to that audit file, then that exception will bubble back up to the calling code and the exception will be thrown here. So auditing is a pretty handy little addition, though it's not as widely used as I think I initially expected, but it does cover that scenario pretty reasonably.
And I'll be honest with you, I have never seen that before. I didn't even know that feature was there. So that might be the case for a lot of folks as well. Like a lot of folks might not have known that. So it's really cool that you'll be able to share that. Looking at some other questions too. So I know we have about 10 minutes left, so I want to make sure we crank out some more of these. I'm going to show this next one. This is also coming from YouTube, and this is from Lucian. And Lucian is asking, what would be some good sync/internal tools to query your data? And Nick, I think you have some interesting suggestions here, don't you?
Well, there is. I would be a bit biased, I think, when we're.
Yeah, that's okay. This is your show.
Yeah. So there. Okay. So I think the number one rule, though, for a start is send the data to a sync that you'll have access to, or a location that you'll have access to when things are going wrong. So if you're in an organization where you don't get access to the database, or that's only available to a small number of DBAs, then don't send it to the database. But if that's absolutely the only bit of production data you've got access to, then send the events there. The product I work on day to day is also built around that scenario, so we can add it. I'll give you a little demo of Seek. Oh. And sorry, it's not my usual keyboard, so my typing accuracy is down today.
Sure, that's okay.
So Seek is a web service that runs as a central log server. And if you send events there, if my code still compiles and runs, hey, you can see them in your browser interface. Oops, sorry. If Seek is in fact running. It's not because we didn't. Sorry.
Oh, no worries.
Demo.
Got it running.
So Seek usually runs as a Windows service or as a Docker container. Because this is my dev laptop and I spend a lot of time doing dev on it, I run Seek as a console app. But of course, in the real world, you'd run that as a Windows service. Hey, you can see that our self log output actually there produced an exception for us. So we can see that we couldn't send those messages via HTTP because there wasn't a connection. So you get a self log demo as well for all of our trouble.
Nice. But that's good because, like you said before, like it didn't crash your app, right? It kind of just failed silently in the background.
5341. Am I running the right thing here? Localhost 5341. Handshake failed due to an unexpected packet format. This just might not be the day for a demo.
Is it because you have that compact JSON format?
No, sorry. It's because there's HTTPS in the URL. Pardon me.
Oh, got it.
Yeah, this is where we should have prepared one earlier. So now you'll see hello.net at 7 in the Seek UI. And if we were to send another event through and we give this one a different name, I can't remember the name of the commenter, but Lucian. Possibly. Apologies if I've got your name wrong there, Lucian. Then we'll see that one pop up in the UI, and if we want to search for name like Lucian, then we can get that one there. Or if we want to search for hour is greater than 5, we get access to those data, those properties that way. So I think that Seek is probably typical of a lot of kind of log server setups where you have Seek run as a central HTTP service, and all of your applications send data across HTTP to the same Seek instance. So I think the key with collecting structured logs is they're really geared towards centralizing logs from all sorts of different locations, and so I think that those kinds of options where you can run a service, especially one that's geared towards use by the dev team. A lot of the time, there's a range of different kind of options in enterprises. The thing that's always been really important for me when I've worked on diagnostics in real world apps for clients has been that the dev team has a way of actually getting through to view and search those logs. I guess that's probably not such a radical concept now. It's almost not worth saying because we've really become a lot more comfortable with that whole DevOps concept.
Right.
But definitely for me, originally, one of the toughest things when setting up good diagnostics on the apps I worked on was to negotiate some kind of location for log collection where the actual dev team could view logs on a day-to-day basis, because you don't really just want to be viewing your logs when things are going badly. And that's how we mostly start setting up structured logging. Like the number one reason that people come and download Serilog, I would guess, is my app crashed in production. My site was down. I didn't know what was going on. I need to collect exceptions or errors somewhere. And so that's sort of stage one. You set up something like Seek and you send your errors or exceptions in there and you can go to it when things go wrong. But once you start collecting all of those logs as your system runs, you start to really get a feel, if you look at those logs all the time, for what normal is. And you might actually view those by charting or using dashboards and alerts, those kinds of things to define normal. But even so, just being able to open up your logs each morning, say if your app's running 24/7, and taking a look at what your code has been doing, really makes debugging things faster when things go wrong, because, well, you also might spot problems ahead of them actually occurring, but you get a real feel for what the day-to-day kind of operation of the system is. And if things start behaving differently, like if warnings start to appear that are not the normal warnings, or or just if code paths start to be used that you didn't really expect to be used. Often you can get ahead of, like it's definitely much nicer when you're a developer to spot bugs before users do, like 100% nicer or 1,000% nicer. So I think having a location that the development team can go and look at logs and not just on an exceptional basis is probably more of a political point than the technical question that I think was being asked. But but really getting to know your logs while you're working through development, and then using your logs for debugging when you're testing, and then viewing logs when things are actually going right as well as when they're going wrong, is the most important practice. Like if you were to kind of, apart from logging itself, like if you took if you tried to kind of picture logging in that set of practices that we use for building reliable apps today, I think alongside, say, unit testing and continuous integration and inversion of control, using your logs through the entire development process is one of those techniques that, to me, I think is irreplaceable. But then I guess that's the DevOps mindset, and we go from kind of being second level support for when the app is broken to being kind of responsible for how the app runs every day.
Yeah. But then for me, the huge benefit for logs is always, instead of me like trying to dig through and figure out, oh my gosh, like what happened in production, now we've been doing this thing since development time and since QA time, in terms of like collecting these structured logs and using whatever query tool we happen to be using, whether it's a database or Seek or something like that, to really understand like the types of data that we're capturing, and also to the way that the application is flowing. And so now when we get into those, on-call scenarios, or, someone rings you up on the weekend on a Saturday and it's 2:00 in the afternoon, hopefully we could more quickly get to an understanding about what the problem is and where the root cause for some of that stuff is.
Yeah, absolutely.
All right, so a few more questions really quick. We're running low, but I definitely want to get to our folks that are with us online, because there's just so many great questions coming in. So this one is coming in from Twitch, and someone's asking, what do you recommend to start logging? I'm guessing. So what do you recommend for an existing application that has no logs? It pretty much is what they're asking.
Oh, an existing application that has no logs. Yeah. That's tricky. I think an existing application that has text logs is also a tricky scenario to approach. I think you'll be quite pleasantly surprised, especially if it's, say, an ASP.NET Core application, which I guess is the majority. If you actually just enable the logs at when the app starts up, you find that a lot of the .NET code now is already instrumented with logging. So if you enable logging in a .NET Core app or an ASP.NET Core app, you'll immediately get logs that include information about web requests and unhandled exceptions. It's really built into the framework now, and it's excellent to have that as kind of the baseline for diagnostics. And then over time, you might want to improve those logs, because I think generic logs that frameworks produce, they're useful if you're debugging kind of your interactions with the framework. But for debugging your app, you tend to eventually want to have really domain-specific logs that talk about the things that are actually going on in your app. So you might enable logging just by calling use Serilog on your ASP.NET Core configuration, and that's generally just about enough. Maybe you want to configure the console sync. You'll immediately start getting logs about requests starting and controllers being selected and responses starting and status codes. And that's enough of a starting point that if you were working from nothing today, you could start to actually get some observability out of an app. And I think then it's just a fairly natural process of improving that by adding your own events.
Right. We seem to have a lot of questions about logging to or logging from Entity Framework. I'm looking. I'm just scrolling through the logs. There's definitely like 3 or 4 questions here that are asking about that. So I definitely want to bring that up. I'm trying to find like the first person that brought this up. Right. We have a question here from Daniel. Daniel's coming to us from YouTube, and he's asking, what about logging the EF core queries? And I actually looked this up really quickly. I'm going to paste this in the chat for everyone to see. But I looked this up, and it seems like if you want to log or get the queries from Entity Framework, you have to have an iLogger factory, and then you have to wire that up when you do your on configuring on your data context, your Entity Framework data context. I don't know if there's anything special we need to do for Serilog to play in that world, or is there a factory for Logger factory?
Yeah, so I think there's a long thread somewhere on a Serilog repository about how to get it all configured. Unfortunately, Entity Framework, as far as I can tell, and see, I should probably add the disclaimer: I don't use Entity Framework in anything I work on day to day, so I'm probably not the right person to field the question ultimately. But if I recall how it was set up in the beginning, Entity Framework had a dependency on the logger implementation rather than just on the logger interfaces. And so I think that made it quite difficult to switch Serilog in to its logging output. I've seen people though successfully capturing all of that info from Entity Framework. So I'm 99% confident that it's that's possible now, but I don't have the info on hand to be able to properly answer your question there. Sorry.
Yeah, and I could take a look at it as well. And if folks, like I've been posting our social media accounts and whatnot in the chat. If folks want to follow Nick or myself and just follow up with us, we can make sure that we get the right information to you, or direct you to the issue, or maybe even send you a sample so you could see
definitely
get that thing running. All right, Nick. So we're pretty much at the end of the show at this point. We've had tons of great questions, and you've shown us out like a really quick sample of how to get started with Serilog. So before we tune off, I just wanted to ask, is there anything in particular that you wanted to let our folks know about? Do you have any, last words or anything like that? Like things that you want folks to pay attention to as they try out Serilog in their applications?
There's nothing that's kind of burning to pass along, but I think that I think that at this point in time, just you're more than welcome, please, to come by the Serilog project, and you can find us on GitHub at github.com/Serilog/Serilog if you want to find the root repository. But there's also a fantastic community on Stack Overflow who follow the Serilog tag and provide answers over there. So often, like, one of the big challenges in open source projects is that the bandwidth kind of required to maintain that core project is very, very high, because like everybody using every possible kind of component in the whole Serilog ecosystem comes to the Serilog repository for support. We're really trying at the moment to encourage people to post their questions to to Stack Overflow first, because not only is there kind of 100 times more people watching that tag over there, you get access to people with more diverse kind of knowledge about Serilog when you answer questions on Stack Overflow, where I think coming to the core project to ask a question, you'll find people like me who are working on the kind of core nuts and bolts, who might not have the same familiarity with things around the periphery, like say Entity Framework or different kinds of sync configuration issues. So definitely check out Stack Overflow as well. But then if you do raise a question there and send a link through on Twitter or on our Gitter channel, which is gitter.im/Serilog/Serilog, then by all means people will take a look at that link and add an answer on Stack Overflow if they can.
Yeah, and then as you're saying that, I'm just looking for the Gitter channel right now. I'm just sharing this with folks in the chat. So I just shared the link to the Stack Overflow one that we mentioned, and then I also shared the link for that cool. Gitter channel for Serilog. So again, if folks want to check this out, make sure you go head over to, I think it's serilog.net, and that's the main page. You can check them out on GitHub. We just shared the link for the Gitter channel, and then also if you have more questions, feel free to go ahead and pop them over into Stack Overflow, or like we mentioned before, make sure you follow Nick on Twitter, and you could send him tons and tons and tons of questions. Make sure you wake him up when he's sleeping.
Cool.
But thank you for everyone that joined us. We really appreciate it. Again, I just want to acknowledge some more of our guests. I see we have some folks here from the Ukraine. We have some folks here calling, listening to us from Johannesburg. Folks from all over the world, all over the United States, all over Europe, in South America. I saw some folks in here from Brazil too. Thank you all so much for spending some time with us today. And again, we do these things every other week. If you like these types of conversations and episodes and whatnot, we might be able to do them every week. But you got to tell us so I can make the case, right? So if you definitely like these, let us know. Post a message in the chat or send us a message privately if you want to, and we can try and have more of these types of discussions with really interesting folks in the .NET community. Folks like Nick and others that are doing really cool things. Now,
Awesome.
with that being said, again, thank you all so much, and we're going to see you all again in 2 weeks. So bye, everyone. Thanks for watching.
Thank you all. Goodbye.